All right, we did a little bit of this in the last, looking at example 1, but let's just sum it up here. So a continuous random variable x, probability density function f of x, satisfies two properties. Well, the first one is that f of x has to be positive. It could also be 0, but definitely we can't go below the x-axis. The second property is that we have to have a total area of 1. So if I go from negative infinity to infinity, so all of my x values, find the area under the curve with respect to x, it has to be 1. If I want to find a specific area between a and b, then I'm going to take my integral between a and b. If I want to find the mean, I'm going to take the integral across the whole domain. And it's possible, so as we saw in our example above, we went from 0 to 10. I'm still looking negative infinity to infinity. It's just that on this side and past whatever this value is, it's 0. So then there is no area in that section. So I could still say this formula, negative infinity to infinity, of x times f of x. So this connects to our comparison. So if I have my discrete random variables, I do the sum of x times the probability of x. In continuous, I do the integral, but the integral is really just looking at the sum of all the areas, or the total area, and I do the same multiplication. Here, my probability is finding the area under the curve. Variance is going to be negative infinity to infinity x squared times f of x minus this quantity squared. So that ties in with our discrete, where I have e of x squared minus e of x quantity squared. Mode is found by not even solving, but finding the max. The median is found by solving the equation where I go from negative infinity to some value a, find the area under the curve. So area under curve of f of x is probability, and I want that to be equal to 1/2. If I look in my formula booklet, I can see that for expected value of continuous, I get my x f of x dx formula. For variance, I get the same thing. So I have this formula, but the more useful one corresponds to this more useful one for discrete.